Fun Sock Friday, the most lit day of the week, the 16th of April. You guys will be able to solve. To me, that is the wrong one on that one. You guys have to find, identify parallelograms, find measures. Find, identify parallelograms, and find measures. So we talked about some different shapes the last few days. Okay, we talked about polygons. We talked about these different types of polygons based upon the number of sides they have. Kenny, been away. And we said, hey, Kenny, thank you. Said, depending on how many sides they have, we'll call it a different polygon. And now we're going to be talking about specific types of a type of polygon. So what's a four-sided figure called? Quadrilateral. Now we're going to be talking about more specific types of quadrilateral. So you know how we did a deep dive into triangles for a long time? Okay. We're going to do a much smaller deep dive into quadrilaterals. By much smaller, I mean 3 sections.
Please don't remind me.
Yes.
We've got to stop so we can listen to Mr. Fossil so we can understand what's going on so we can get our homework done.
Some of us don't learn by not talking and whatnot.
Well,
I struggle to stay engaged when I just sit here.
Okay, so could you just dial it back like a smidge? Because I struggle to stay engaged when you are talking. So and there's other people in here that feel that same way.
Whatever.
So we have to make it work for everybody, not just some of us.
A parallelogram is a quadrilateral, it's a more specific type of quadrilateral, and it has both pairs of opposite sides parallel. Now I think that name's pretty straightforward for what it is. It says it has both pairs of opposite sides parallel, and so it's called a parallelogram. Does that make sense why that would be connected there? Okay, so what does parallel mean? Raise your hand and tell me what parallel means. Okay, Seth.
They will never intersect.
Okay, they'll never ever intersect, never ever touch. Okay. So here, can somebody give me an example of 2 sides of this parallelogram, A, B, C, D, that are parallel? Dylan.
AD.
Okay, side AD or segment AD is parallel to what?
It's parallel to BC.
Side BC or segment BC. Very good, very good. And now what do we see marked on sides AD and side BC? The little arrow, right? That arrow tells us they're parallel. Now, we see 1 arrow here. Do we see 2 arrows somewhere else? Yeah, there's 2 arrows. Does that mean they're parallel to the ones with 1 arrows? No, but they're parallel to the other ones with 2 arrows. So what? Somebody give me another pair of parallel sides here, okay? Quentin?
AB.
Here's side AB and what else? Quentin, AB and?
DC.
And side DC. There we go, there we go. So those are also parallel. Notice they're opposite sides, right? It can't be consecutive sides. It can't be next to each other because then they'd be touching, wouldn't they? They have to be opposite sides or parallel. Yes, Kenny?
Our school has a BC before COSL, and currently we're in DC during COSL. And when you're done here, we'll have an AC.
After COSL?
Yep.
I appreciate that. That's good, that's good. All right.
Time to find the years from now on.
So we're in 3DC. This is my 3rd year here. All right. Naming parallelograms. When we name triangles, we said we could name any 3 points in any 3 orders, right? In any order, any 3 orders. Any points in any orders, and it was okay. For a parallelogram or any polygon, we said we want to pick a point and go clockwise or counterclockwise. I guess for you it would be clockwise or counterclockwise. Okay? So who can give me an example of a name for this parallelogram here? Dylan.
ABCD.
Awesome, ABCD. Now I'm also going to do a little shape here. What does that shape look like?
Looks like this.
It looks like a mini parallelogram, right? Is that something we've done before in geometry? We draw a mini version of it to name it? Yeah. Triangles, we've done that. We've done it for line segments. We've done it for lines. We've done it for rays. We've done it for angles. What's another name we can name, Kenny?
DCBA.
Yeah, we could do parallelogram DCBA. There's 8 different names we could do for this. Yep. 8 different names we could do for it. You can start at any letter, and you could go either direction from each letter. Kenny's testing to see if my theory is true. Or my statement's true, I should say, not a theory.
Very good.
Is it checking out, Kenny? So here's the math that supports that real quick just for you, Kenny. And for anyone else that's interested. So we have 4 different starting places, right? So that right there gives us 4 choices. Now from each of those 4 choices, how many choices do you have? 2. So let's say from choice A, B, C, and D, from each of those, from A you could go to B or D. From B you could go to C and A. From C you could go to B and D. And from D you could go to C and to A. So we count these number of choices, 1, 2, 3, 4, 5, 6, 7, 8. So it's 2 for every one. So we have 4 of these, 2 at each of them. So we take 4 times 2.
I trust your logic. I just want to double check.
Yeah. Well, then did you trust it?
Yeah. It's like, you pose that theory and somebody else has to check it. It's like hypothesis.
All right, parallelogram theorems. We're going to have lots and lots of theorems today. We're actually going to have 5 such theorems today, okay? Quite a few. I missed it. We're going to have 4 such theorems. I thought it was 5. It was 4 such theorems. First 2. A quadrilateral is a parallelogram. IFF. Does anyone remember what IFF stands for? Way back chapter 2. This is the throwback. If and only if. Okay, if and only if. That means this is true if this happens, but also it's only true when this happens. Okay? So that means this is the only time it ever happens. In a parallelogram, a quadrilateral is a parallelogram if and only if opposite sides are congruent. So not only are opposite sides going to be parallel, aka never ever touching, they're also going to be congruent. Meaning they're the same what? Length. Very good. So can somebody give me an example here of some congruent sides? Okay, Elizabeth. Okay, side BA and side CD. It doesn't matter how we name it, whether it's like side BA or side AB. No. And I can mark it with 1 tick mark, blessing, blessing, down after, let's forget, blessing, blessing, down after, let's forget. I can mark that with 1 tick mark on each. Can somebody give me another example of a pair of congruent sides here, okay? Dylan, go ahead.
AD, BC.
Yeah, sides AD and sides BC are congruent as well. So I can mark that, but I have to do 2 tick marks. Why do I do 2 tick marks on that one?
That's not a square.
It's not a square necessarily. And do we know if they're congruent to the previous congruent sides? No, we don't know. They could be, I suppose, but we don't know that. But we do know they're congruent to each other.
It's after Dylan before Papa.
So there you go, there you go. So,
More common.
there you go. Seth, what is your question? Okay, now on here, we're saying that if it's a parallelogram, Seth, if it's a parallelogram, the opposite sides are congruent. I'm also saying if the opposite sides are congruent, it's a parallelogram. It works the other way. If you know this about it, it's that. If you know that, it's this. It works both ways. If you know the opposite sides are congruent and you don't know they're parallel, it is a parallelogram and they are parallel. That's enough information to tell us. The other theorem of this is a quadrilateral is a parallelogram if and only if opposite angles are congruent. If opposite angles are congruent. Who give me a pair of congruent angles here? Okay, Seth.
Angle A and angle B. No, angle C.
Angle A and angle C. Those would be considered opposite. They are as far from each other as possible, aren't they? Mm-hmm. Okay. Angles A and B, as in boy, are not opposite because they're consecutive. They are next to each other. They are adjacent. Okay. Can somebody give me another pair of congruent angles here? Okay. Kenny.
Angle B and angle D.
Very good. Angle B would be congruent to angle D here.
That's not a question.
And how many arcs am I going to put on this one?
2.
2, because we don't know if they're congruent to the first ones. They could be. We don't know. Kenny, what's your question?
So it's only a parallelogram if it's shaped like this. Like it can't be a different shape, or like one of the sides can't be lower than the other.
Great question. Great question. So Kenny was saying, hey, it's only a parallelogram if it's shaped exactly like this. Yes, but no. Parallelograms can come in different shapes and sizes, but these things have to be true about them. So a parallelogram still for it to be a parallelogram, it still has to have opposite sides parallel. Both pairs of opposite sides have to be congruent. and both pairs of opposite angles have to be congruent. Those are all things that would be traits of a parallelogram, but it also could still look different than the picture described.
So could you have like side AD be short or longer than side BC?
No, because that would break this first theorem we learned.
Okay.
Yep, great question. So if anything breaks one of these theorems, it's not a parallelogram.
What is it? Just a quadrilateral?
Yeah, it would just be a quadrilateral or maybe a different type of quadrilateral that we'll learn later.
Okay.
Yep.
Quadrilateral.
No. No. We'll learn about rhombi next chapter, a little bit next section.
So then could the angles be like more or less harsh? Or still be like tip more?
Yep. So basically you can think of it as you can kind of like angle it less and more. As long as everything's balanced out.
So a square is a parallelogram.
A square is a type of parallelogram.
This is suspicious.
All right. So we'll do a whole activity about it. All right, example 1 here. We have a shape here. This is a quadrilateral. What kind of quadrilateral is this?
Parallelogram.
How do we know it's a parallelogram, Seth?
The lines,
What about the lines? Arrows. What do those arrows tell us?
they are parallel.
Both pairs of opposite sides are parallel. So by definition, it's a parallelogram. If it's a parallelogram, what do we know about side AD and side BC? They're congruent. So then can we make an equation here to solve for y?
Yes.
What would that equation be, Kenny?
Y equals -6. Or not equals, minus, y -6. Yeah, that. Plus 12. No? I don't know that.
No?
You don't know.
Landon? Y minus 6 equals 12. Whenever two things are congruent, always set them equal. If they're the same length, that means these lengths are the same. We can set them equal. If y minus 6 equals 12, can we solve that equation for y? Sure. Ryan, how do you solve that equation for y?
You add 6 to both sides.
Darn right. And y is
18.
18. So that made no sense?
No, it does.
Okay, so y is 18. We found y. Did we find x yet? No. Okay, well, wait. If this is a parallelogram A, B, C, D, if you will, what do we know about angles B and angles D? They're going to be congruent, equal in measure to each other as well, okay? So what kind of equation can we set up there?
64 equals 2 times
64 equals 2 times x
x.
or 2x. Once again, when things are congruent, we set them equal. Congruent tells us that to set them equal.
You're mad.
They called me a madman. All right. Well, what do you do to solve this equation now?
You divide by 2 and I found the answer.
Divided by 2. And then, Dylan, what is that answer?
32.
32. Questions on that?
DC will be, or CD will be a sad day.
You mean AC?
Well, no, like CD will be like an exact date. Opposite day.
Oh, wow. Dang, dude. Dang.
But then we'll have AC, which are after opposite.
All right. I don't even know how to react to this.
We bury
All right.
you without your socks.
Bury you.
You can just bury me in my socks by then, probably. That'll probably be enough.
Suit out of stock.
All right. Oh, there we go.
Get a
And then
tattoo
we
of a
flip
fun
your
sock.
car.
All right, guys, go ahead and continue on right below this. We have another theorem. A quadrilateral.
And then we put their car in your
Shh. Set. So now's the time to stop when I start switching us, okay? If a quadrilateral is a parallelogram, so we're saying if it's a parallelogram, then we'll know this is true. Does that make sense? So we're not saying this is true of every parallelogram. We're saying, this is not true. We're not saying this automatically makes something a parallelogram. We're saying this is true of every parallelogram. So, if a quadrilateral is a parallelogram, the consecutive angles are supplementary. What does it mean to be supplementary?
Equals 180.
Add up to 180. If you want to know how to spell out supplementary, it's like this. But I also will often just abbreviate after the P. So here, can somebody give me an example of two angles that would add up to 180? Tyler, can you give me an example of two angles that would add up to 180 on this picture up here? So on this picture up here, we don't see any numbers. So we'd say like angle this and angle that. What does it mean to be consecutive angles? Kind of. What's that mean? What do you mean by straight from each other? Explain that to me a little bit more. They're right next to each other, okay? So Tyler, it sounds like you can pick any two angles that are right next to each other. So what angles do you want to pick?
D and C.
Cool. So the measure of angle D plus the measure of angle C would give us 180. Tyler could have picked literally any two angles that were next to each other because they'd be consecutive. Thus, they would be supplementary. Here's how that math/logic works. Let's say, for example, angle A has a measure of, let's call it D. No, let's call it a different letter. Let's call it G. Let's say angle A is G degrees. Okay, what would angle C be then? G. Let's say angle D has H. So what would angle B be? H. So we could add all four of these up. And what would we get if we had the four angles of a quadrilateral? 360. Seth is correct. So we could add G plus H plus G plus H equals 360.
Couldn't you just simplify that as 2G and plus 2H?
Very good, Seth. 2G plus 2H equals 360. So we can actually do this math called factoring here. We learned this back in algebra, where you can take a 2 out of both the 2G and the 2H. They have a 2 in common. Factoring is the reverse of distributing. So we say they both have a 2. So we take a 2 out of each of them. If we were to distribute that 2 back into the parentheses, would we get what we had a moment ago? Yeah, we would. So what we could do now is we could actually divide by 2 because 2 is multiplying with G plus H. So mathematically you're able to divide there. And G plus H equals, what's 360 divided by 2? 180. So notice, no matter what they are, we just use two letters, two variables. These two angles have to add up to 180. That's your opinion.
And mine's right, because it's my opinion.
Jaw to jaw. All right. Example 2. Find the values of x and y in this parallelogram. I want you to go and try it. Once you have it or have questions, raise your hand. Now, before we get into some writing equations here, what do we notice about angle x compared to, angle C compared to angle A? What are angle A and angle C? They're congruent because they're opposite angles in a parallelogram. So what does x have to equal? 120. Before we do anything else, we can know that. Now, what do we know about angles A and angles B, or angles B and angle C, or angle C and any two consecutive angles?
A and B.
They have to equal 180.
They have to add up to 180, right? They have to be supplementary. So, Seth, thank you. Dylan was already talking there. So, Dylan, what can we do to find the y?
I just turn 180 or minus 120, which is 60.
Yeah, and you get 60. Alternatively, if you prefer,
Because I would there you don't have to do the whole equation.
alternatively, if you prefer, you could go and do a whole equation and do 120 plus y plus 120 plus y equals 360. And you can still end up getting it to be y to be 60 because you get 2y equals 120. Questions on that? He's part of the custodial staff. Continuing on then. Our fourth and final theorem of the day. A quadrilateral is a parallelogram. Here's another if and only if. So this goes both ways. This makes it a parallelogram, but it's also a trait of a parallelogram. If the diagonals bisect each other. Remind me, what does bisect mean? Okay, what about in the middle?
Like it cuts through
It cuts it in
half.
half. So that means diagonal AC, okay, it's a diagonal running across non-consecutive vertices. Diagonal AC cuts the other diagonal DB in half. So if AC cuts diagonal DB in half, that means D to E is congruent to what?
E to B.
E to B. Very good. Now it says both diagonals bisect each other, right?
Yeah.
So that also means that the diagonal D to B bisects the diagonal A to C. So what two segments would then be congruent if that diagonal is bisected?
E and EA.
Yeah,
Or AE,
either way. That diagonal is also cut in half. So both diagonals are cut in half by the other diagonal. Does that mean all four parts of diagonals are congruent to each other?
Yeah. So that means if, like,
Does that mean E to C is congruent to E to D?
no.
Not necessarily. Could they be?
Yeah.
Yeah. Do they have to be? No. E to C has to be congruent to E to A, but not to anything else. So on example 13, let's use this theorem. Okay, we've been learning a theorem, use it. Learn a theorem, use it. Learn a theorem, use it. We're going to do it one more time. We learned a theorem, we're going to use it. So we have this shape, and what kind of shape is this? Parallelogram. How do we know? Presley, how do you know it's a parallelogram? And yeah, what do those arrows tell us? The arrows tell us that these sides are parallel. Very good. And if both pairs of opposite sides are parallel with these obnoxiously big arrows on this problem, then we know it's a parallelogram. Well, if it's a parallelogram, what do we know about these diagonals? They cut each other in half. So we can mark that. 12 over here is congruent to this. What's an equation we could set up to find x now? Dylan?
You can do 3x plus x equals 12.
Very good. Could we solve that equation?
Yeah.
Sure. What's another equation we could set up to find y? Same thing? 3x plus 6 equals 12?
Now the 2
Elizabeth.
9 equals 27. I'm sorry.
Very good, because that diagonal is also cut in half, so we can mark those as well. Not a bad idea to mark the information on your pictures, right, Tyler? Would you agree? Good, good, good. I want you guys to both solve I want you guys to solve both of these equations.
Sure.
All right, the first equation, we subtract 6. 3x is 6. Divide by 3.
Equals 2.
X is 2. Second equation, we subtract 9.
Equals 18.
2y equals 18.
Divide by 2.
Divide by 2. Y is 9. Now, could we plug y back in and make sure it gets 27 to equal 27?
Yeah.
Sure. Could we plug x back in and make sure that 3x plus 6 gives us 12 to equal 12? Yeah, we could check those things, okay?
Do we need to?
Don't need to, but you could. Questions or anyone still need that?
Why is there an E in
May I use the restroom, please?
Yes, good luck. Actually, are you able to wait like 5 minutes? Cool. All right, beans. Parallelogram overview. We learned 5 main things about parallelograms today. I want you to tell me those 5 things. So I want you to raise your hand and tell me one of these 5 bullet points. Okay? I want you to raise your hand and tell me one of these 5 bullet points. Kevin. Opposite sides are congruent. Okay, I'm going to mark that on my picture. 1 tick mark, 1 tick mark, 2 tick marks, and 2 tick marks. I'm going to mark that on my picture. Opposite sides are congruent. Okay? Another one. Seth.
Opposite angles are congruent.
Opposite angles are congruent. Okay? I'm going to mark that. Angle D congruent to angle B. Angle A congruent to angle C. Okay? I don't think so.
No.
Okay, that's another thing we know. Dylan.
Diagonals bisect each other.
Okay, the diagonals bisect each other, cut them in half. So I'm going to use a different color on this one actually, so it stands out a little bit more hopefully. And I'm going to use 3 tick marks for A to O and 3 tick marks for O to C, 4 tick marks for D to O, and 4 tick marks for O to B. Notice I had to go up to 3 and 4 tick marks because 1 and 2 were already used. We have 2 more bullet points we need to fill in. Opposite blank are blank, and consecutive blank are blank. Okay? I want 2 new people. I've had 3 different people so far. I want 2 new people. So if you haven't answered one of these 5 yet, you're eligible. Kenny.
Consecutive angles are congruent or supplementary.
Consecutive angles are supplementary, meaning they add up to 180. Now, there's not really any drawing we can do or labeling for that one.
Oh, yeah.
Presley, do you have another one? Or is that yours? Okay. Anyone have the last one?
I do.
Someone new had the last one. Go back and flip through your notes if you need. Do you think you know it?
Triangle.
Ooh, not quite, but worth a try, Try something. Opposite triangles.
I don't know. I haven't tried. I called you a goof last night. My mom
I'll
was,
say.
yeah, but he's your goof.
Ryan?
And she was like, what would our life
Okay, guys, what's off? Opposite sides are what? Parallel. Is that the definition?
It's the first one.
It's the first one. It's the definition. Opposite sides are parallel. We can mark that. I'll do 1 arrow on on one set of sides, 2 arrows on the other set. It doesn't really matter which set I do 1 and 2.
I actually didn't see this.
So, that is our final one. Opposite sides are parallel, okay? Now, I was okay with doing those really in any order, right? Okay? That's our definition of it. So, if we have a parallelogram, we know all 5 of these things are true. I try to put those in a nice, organized spot for you here. So that way later you can go back and this is a nice reference for you, okay? Does that make sense?
May I use the restroom now?
Yes, good luck.